Now, we are going to solve this given oblique triangle. To solve any oblique triangle, we may use the law of cosines or the law of sines. But we need to first determine the given measurements before we could declare which formula to be used. In this given oblique triangle, one side is given, and you have your angle here and this angle. But take note that that side is not included on those two angles, or not between the two angles. This is an example of an AAS or SAA oblique triangle situation. And for this specific type of example, we will be using the law of sines. The law of sines will allow us to use the ratio of sine angle and its opposite side, which will be equal to another ratio of sine angle and its opposite side. But first, let's try to label this. What if we're going to label this as A? That's 6 units. This would mean 73 degrees is your angle A. If I'm going to label this as angle B, the side directly opposite it, which is B, side B, and the remaining angle is C, and this is your side C. In short, we're looking for the measurement of sides B and C, and the measurement of angle C. We can use the law of sine here using this formula. The sine of angle A over side A is equal to the sine of angle B over its opposite side B, which is also equal to sine of angle C over its opposite side C. We just need to simply input all values here. But before we go to this, there's one item here that we could solve even without the use of the law of sines. I'm talking about the measurement of angle C. The measurement of angle C can be computed using the triangle angle sum theorem, which states that for any triangle, whether it's oblique or not, the sum of all interior angles is equal to 180 degrees. In short, we will just simply subtract the two given angle measurements for B, which is 80, and A, 73, from 180 degrees. This means, again, less 73 degrees and then minus 80 degrees. Let's try to use this calculator. We have 180 minus 73 and minus 80. Take note that the answer is exactly 27 degrees because the measurements of angles are given to be exact. So again, the measurement of angle C, since it's exact, we will use equal to 27 degrees. For this, we can now input all of the given measurements, including this angle measurement, in our formula. So our formula could stand sine angle A, which is 73 degrees, over your side A, which measures 6 units, equal to your sine B, or which is 80 degrees, less side B. And finally, you have your sine C, and since C is already given as 27 degrees, you could use that to solve for C. We're comparing a ratio with complete details, such as this one, to solve for the rest. So we will be pairing this first to solve for B. Let me increase portion of this area for more computation. So let's try to solve side B first by pairing that. We'll be using the fundamental law of proportion, or the very well-known cross multiplication, to solve for B. By doing that, you have B times sine 73. That will be your first result on your left-hand side. B sine 73 degrees must be equal to 6 times sine 80 degrees. Next, we will be dividing both sides. by sine 73 degrees so that it can be cancelled out here. And again, we do the same thing on the other side. So B can be computed as the result of this entire expression. Let us use this scientific calculator. So we're just going to input all details at once, but please don't forget that you could always use parentheses to separate the numerator from the denominator. We're going to use parentheses, 6 sine 80 degrees, close, close, be divided with sine 73 degrees. Take a look at the result. That's 6.178832, so on and so forth. Let's round it off into 2 decimal places. That will become 6.18 units. And since we are rounding off, we will just use approximation instead of equality. So that's 6.18 units. That's the result for side B. Let's go now to solving side C. Now, some of you might use the already solved side B measurement of 6.18 units to solve for C, but there might be some complications later on as to the second decimal place or the 100th place, because 6.18 is already a rounded off value. So my suggestion is you just use the first and the more complete detail, a ratio details with the last one here. So when you're going to cross multiply this, take note of first ratio and the last ratio. You will get C times sine 73 degrees must be equal to 6 times sine 27 degrees. Divide both sides by sine 73 degrees, because that will be cancelled out here. The other side will have sine 73 degrees as well. So C is simply the result of this entire expression. Let's use this calculator. And again, we will use appropriate parentheses to separate numerator expressions and denominator. You will have 6 sine 27, close, close, divided by sine 73 degrees. So your result is very small. That's 2.8484, so on and so forth. We are going to round it off to 2.85 units. So again, when rounding off, we will be using approximation 2.85 units. It is 85 because when you rounded this off to 2 decimal places, it will go up. So these are the 3 unknown measurements for this given AAS or SIA oblique triangle. We already solved the measurement of angle C first using triangle angle sum theorem, and used the law of sines to solve for the remaining side measurements. Before we end this video, we can always use the concept that the side directly opposite the largest angle to be your longest side, and conversely, the side directly opposite smallest angle to be your shortest side. Looking back at our given, 73, 80 degrees, and you have 27 degrees here, it's the angle B, which is the largest angle. So it would mean that B, or side B, is your longest side. Looking at the values, A is 6, 6.18, and C is 2.85. So very small difference. It's still the correct one. B is the longest side. And this is actually the small difference to the side units is actually given to us. A small difference in the angular measurements as well. On the other hand, the measurement of angle C is very small to be 27 degrees. That's the smallest angle. That's also why side C is also very short, 2.85 units. This is how we solve an example of an AAS or SAA oblique triangle.